8B, hypothesis testing for proportions. So we're actually going to go through the process to be able to finally mathematically answer our question about Coach Rivers' free throws. So to refresh your memory, he claimed to be an 80% free throw shooter, but in our experiment, he only made 32 out of 50, which is 64%. So if P equals 0.8, if the true proportion of free throws that Coach Rivers makes is 80%, would that sample result of 64% be normal? Unlikely? Really unlikely? How can we be sure? And to do that, we perform something called a z-test. Okay? So things that, two values that we need to understand. The first is called a p-value. All right, and this is the probability of obtaining a sample statistic that is as extreme or more than the one calculated from your sample. So in plain English, when we talk about our Coach Rivers example, the probability of somebody making 32 out of 50 or less, all right, what is that probability? So we kind of estimated this the day we did our experiment with the dot plot. And we counted how many dots were at 64% or less, and we found the probability of that happening. That is one way to estimate a p-value. From now on, though, instead of having to make a dot plot every time, we're going to use Desmos to mathematically find a p-value. The other important thing is, what is our level of significance? Okay, so we think of this like a cutoff value. And so if something, remember we talked about on our dot plots, like, would you consider that super rare? You know, if I flip a coin 20 times and I get 12 tails and 8 heads, would that be rare? Super rare. Okay. Would, you know, how far do we have to go before you consider it super rare? And different people might come up with different numbers. So that's why we set a level of significance. That is our cutoff value. And if our p-value is less than our level of significance, then we reject the null hypothesis. We consider that to be super rare. Okay, the significance value is given to you in the problem. Some common ones that you'll see, and these aren't the only ones, but these are the most common ones, like 0.01 and 0.05. So if I set my significance level at 0.05, what I'm saying is anything that happens less than 5% of the time is considered rare. Okay, so this is our cutoff value. All right, when we do a z-test, we need to identify our null and alternative hypotheses like we did in our last lesson. We need to identify alpha. We're going to find the p-value in Desmos, and then we're going to compare that p-value to alpha to determine whether we're going to reject or fail to reject. Right, and then the last piece is we're going to write a one-sentence conclusion. Okay, so let's go ahead and use Desmos to find our p-value for our Coach Rivers experiment. So in Desmos, it's going to look a lot like the confidence intervals that we just did. We're going to do the plus sign, and we're going to go to inference. Okay, and let me scoot this over so you guys can see. We are doing a z-test for proportion because we are talking about the proportion of free throws he made. And just like our confidence intervals, we're going to put in these values for successes. So Coach Rivers made 32 out of 50 shots, and we're going to hit create test. All right, and this time instead of confidence interval, we're going to click the arrow for significance test. Okay, we have to put in what our null hypothesis is. Okay, so we don't think P is 0.5. We think that P is equal to 0.8 because that's what Coach Rivers said, that he was an 80% free throw shooter. Okay, and then we have to pick tails. So this is going to match our alternative hypothesis. So if our alternative hypothesis is less than, then we want the left tail. If it's greater than, we want the right tail. And when we have that one where it's not equal to, that would be both. So in our Coach Rivers experiment, our alternative hypothesis was that he is actually less than an 80% free throw shooter. So we're going to pick the left tail. All right, and Desmos gives us a p-value of 0.002. All right, so that means that the probability that an 80% free throw shooter only makes 32 out of 50 is 0.002. All right, so our p-value is 0.002. And what do we do with that information? We're going to compare it with alpha. So up here in the problem, they told us we're going to use alpha equals 0.05. So we're comparing 0.002 to 0.05. All right, this number is smaller, so that is less than 0.00 or 0.05. So that means I am going to reject the null hypothesis. Anytime my p-value is less than alpha, I reject the null hypothesis. And then the last thing is write a one-sentence conclusion. And just like the confidence intervals, all right, we have a sentence that we can use, okay? Now, it's we reject or fail to reject because the p-value is less or greater, so there is or is not, okay? Notice that these are different colors. Reject, less, and is are all blue, and the other ones are all green. That's because they all go together. So if I reject the null hypothesis, that means the p-value has to be less than alpha, and that means there is enough evidence to support the claim that, and the claim is going to be whatever our alternative hypothesis was, but we're going to write it in the context of the problem. So for Coach Rivers, our null hypothesis was that P is equal to 0.8, that he is an 80% free throw shooter. And our alternative hypothesis is that P is less than 0.8. Okay, but we're going to write that in context. So what does this mean? We have enough evidence to support the claim that Coach Rivers, right, makes less than 80% of his free throws. Okay, so I'm not just going to write symbolically this mathematical statement. We want to talk about it in context of the problem, so this should be words. All right, and that is how you do a hypothesis test.